Yes, a warm welcome from my side also. My name is Fabian Gabs. I'm the sales manager from IMAGO Technology. And today I want to show you something about the AI cameras we have. I will share my screen. Just a second. Okay, so now you should see the screen.
Yeah, we can see it.
Okay, perfect. So today the topic is AI, smart AI camera, simple as a wink, we called it also. And to show you what we present to you today, I have a small agenda for you. So in the beginning, and just a short portfolio to see what we're doing, what our company is doing. Then we dive into what is machine vision, and that machine vision becomes intelligent, following by deep learning for beginners. So this will be interesting for those of you who are new in this field or want to use a very easy to use camera. Then we go into detail in the anomaly detection, where I have also some possible examples for you. And in the end, we go from theory into practical application. So first of all, yeah, the lineup, what our company is doing, basically it's everything around machine vision components. We have like the image processing computers, but also smart cameras, which means complete systems with including CPU power and for image processing. We handle the typical applications in like area and line scan applications, but also more of interest are becoming the topics deep learning, event-based vision, and also condition monitoring, where you check your machines or your manufacturing. And of course, we also have the topic illumination, which you can here see an example of one of our products. So, but now let's go into deep learning. So machine vision becomes intelligent. I mean, most of us already have heard it, and we saw already some people are using AI technology. So I started here with a slide where we say what is artificial intelligence. So basically, it's intelligence demonstrated by machines. So that means that's the difference between the machines and, for example, animals or humans. And that's one part. What we can also have, or what we have to explain, is the deep learning. So what is deep learning? Deep learning, you often also hear in the same sentence with AI. This is a part of machine learning, actually a special part, where we use artificial neural networks with representation learning. So that means we take the brain, the human brain, and try to bring it into the machine. So that means, for example, we have the possibilities to train machine networks, artificial networks, with the benefit of having a machine doing the decision afterwards. So this is the final approach, that you have a machine in the end, which makes the decision for you if something is okay or not okay, if something is from the quality part of view okay for you or not, for example. And this this road we go with this AI topics in I mean, we heard it the last decades already, but nowadays, or the last years, it becomes more and more popular, and also especially because of the technique, the computers are getting more powerful. And for machine vision, what does it mean? What is the impact? So we see that the next generation of vision solutions will work more with the principles of like the human brain or with neural networks than instead of classical data processing. So, but today we want to have a look on a on a product which is which can be easily used from beginners, for beginners as well, also for experts, but also for beginners especially. And this is a so-called VisionCam AI Go. And for example, here you see what's possible. You can teach the camera itself with just 10 or 30 images. That's it. Then you have the camera ready to say, okay, the object you show me later is one of this class. Is it class 1, class 2, class 3, etc. In this camera, there's the easy-to-use software, so that means that you don't need to have image processing expertise. So you don't have to be an expert. You don't have to write the code. You don't have to write the algorithm. Just anybody who is able to use a computer can use this camera. It just takes a few minutes to make the pictures. For example, make product 1, 10 pictures, product 2, 20 pictures, product 3, 10 pictures. And then it takes 1 minute to learn on the camera. So it means the camera will create the model by itself. Takes a minute, and then after the minute, you're ready to go. The camera then can decide between different classes of objects. And for example, the class could be red ball, green ball, blue ball, or a long one, a small one, a wide one, or for example, okay one or not okay one. So it can be any different classes you can imagine. And so this is the first step of deciding or having a machine, basically a smart camera, to decide if a project, if an object which it sees directly in front of the cam, if this object is okay or not okay, for example. Yeah, just to mention, we have as IMAGO, we are experts in this hardware development. So that means the hardware we have here was developed in-house, but the neural network was developed by a strong partner of ours, which is the company Aurobix from Italy, and they invented and developed the special software which is running on the camera and which delivers you the neural network. Okay, so far, I want to go now to the next step, next to deep learning. What is so special about anomaly detection, and why could anomaly detection be so useful? So imagine you have a mass production, you produce a lot of products, and then you want to check if they are good or not. And then it comes to the problem that if you want to use the camera as it was before to decide between good and bad, you always need some examples of bad products, bad images, or you need some examples of defects. And in mass production, it can take a very long time to create special defects, and especially to create let's say 10, 20 products with some kind of defects. So that means it's not easy to have the best training material for the camera in order to generate the model to make the camera able to decide between good and defect 1, for example, defect 2, defect 3, etc. So because of this, it's very helpful to have a kind of anomaly detection, which means I see only the perfect product. I know how the perfect product looks like, and if there's any change in the product, I then inspect afterwards. I check afterwards. Then I get an information. This one is different than the golden one, the perfect one. So this would be then an automatic quality checker, or let's say an alarm for unusual situations. And this would be very, very helpful then for your production line, for example. How could this look like? If you create this anomaly application, of course, first of all, you have to set an image class. This class would be the images of products which are okay, which are good. Second step is learning. The system has to learn, okay, this is a perfect one. Then it's ready, and then you just have to check, okay, what's the outcome of this learning method? What's the outcome of this inference program? Maybe you have to adjust a little bit if it doesn't work as expected, but then it's it. That's basically it. And in the end, you're ready, and the inference program is then able to make the decision to say, that's good, that's okay, or that has an anomaly. And one easy example could be a printed circuit board where you have many different objects on it, and then later you see you see two different ones, and the machine can then pretty easy decide, there was a change, for example, here in the upper right side of this board. So this is quite typical and powerful application. And in the next slides, I want to give you just some ideas of where you could use this at your place, or in what kind of situation you can use it. For example, you have some sweets or pralines, then you can check, are they in the right order? Are they placed correctly for did the pick robot did the right job, for example? Or you have in some kind of food production, like chocolate production, is the chocolate really pure, or are there maybe some some animals, flies, bees, or some other foreign objects inside? Could be used in also check of materials, like here in the wood. Or, for example, if you check the spray can, or even the spray pattern, you could think of to check the quality. Of course, in the place of where you can mount your products in the mounting area, mounting part. Yeah, and for example, the last example is to check for completeness. So, is the set of my product or what I see, is everything complete, or am I missing some specific small pieces which I cannot see directly with my eye? Yeah, so far to the ideas of applications. Last slide is from theory to practical application. So we called it, why wait? Why wait to innovate? It's very really very easy to start your own application. You just have to illuminate your scene. So take an LED illumination. Be sure you have light. Then check out what kind of field of view do I need? So that means what kind of lens shall I take? Then you connect the camera. You connect the camera to the power supply to your PC or laptop, and then that's it. You can start. That's it. AI, simple as a wink, as we called it. And with this, I would like to thank you for your attention, and I'm open for questions.
Thank you, Fabian. There are already a few questions. Looking at the time, I think we can do a few, but we will get back to the rest of the questions. No worries. First question, we do a clear, maybe you could stop your presentation.
Sure. Yeah.
We do a clear plastic and have trouble getting accurate readings to pick with the robot. We can identify the product, but with low accuracy. Any trials been done on clear plastic with your camera?
With clear plastic, I think is it transparent? The meaning of clear plastic? I
would think so.
So, I think it's quite. Okay, we got the yes. It's always a question of illumination. There is some special tricks you can use, for example, with different kind of illuminations and optic tricks where you can handle this. But this is quite specific question already. We could then, of course, I'm happy to answer directly if the question is very detailed. Then we can always also take later.
Okay. What is the maximum number of images that can be captured on the IMAGO?
So there's I think we have 32 gigabyte of storage, so there's plenty of space for the pictures, and for using the models you actually don't need so many. So 10 to 30 should be enough. I mean, you can also take 100 or more, but then in some place you would have an overfitting of the model. But if the question is of how many pictures can be stored, it's a very lot of pictures with this SD card which is inside.
And what are the frame rates you can achieve with your cameras? Inference included.
Which included? Sorry.
Inference included.
Okay. Yes. Yeah. With the processing, this depends, of course, on the objects a little bit, but usually we are in the range of so 30 to 40 pictures per second. We can then calculate and process.
Okay, maybe one short question more, and we will do the rest later. How many classes can you train on the camera?
Basically, it's up to you. We started with a limitation of 5, but nowadays we improved, and so nowadays you can have more classes, up to you. But for anomaly detection, for example, yeah, you just have then the one class for your perfect product, and then everything else is an anomaly.
Okay, thank you, Fabian, so far. We will see each other later in the Q&A.